let's go into the true angle problem example 2. Okay, we're gonna recap our basic rule. Yeah, so first we're gonna verify the accuracy of your two-view projection. Just a view, okay. Then we're gonna insert the full line. Yeah, your full line is your reference plane, in other words, and that's gotta be perpendicular to the projection lines. Yeah, between the two views. You will always have two views, and you throw the projection line in between them all the time. Yeah? So you should get it by now. Alright, so we are now already on the chapter 2. So anyway, unit 2. And then we're going to identify the line formed by the intersection of the two given planes. Yeah, you will always have two surfaces, anyway, two planes. So the line in between the two planes, the line in between the two intersecting surfaces, we call it the line of intersection. So if that line of intersection is not true, length in any given view, we're going to follow the auxiliary procedure like we did, yeah, in oblique surfaces, the same thing, to find the line of intersection in true length. Once we get the true length, we're going to project, yeah, parallel to the orientation of that true length line of intersection, and then go from there. Okay, so that's a deal. Okay, so now this type of approach, we do it when you don't have a true length line or intersection. So how are we going to do it? Let's take a look at it. So here is an example, and you can see the two views given to you. Yeah. So our geometry, when you take a look at it, your right side view, see that surface A and B, you've got to intersect. See, there's a little line right there in between A and B. But your front view, look at that. Yeah, it's a little bit difficult because your surface B is right there, yeah, and then your surface A is on here, yeah. Your front view is a little bit difficult to see, and of course this is which is this line, right? That line in between the two surfaces. And we will, of course, going to do through this auxiliary view technique to solve the true angle, yeah, between the two surfaces. So first, your projectors, so 1, 2, 3, 4, because we have 1, 2, 3, 4, yeah, points. So you have 4 projectile lines. Throw your full line perpendicular to these projectile lines. Yep. We'll pay attention to our line, yeah, of intersection, which is this guy, 1, 2. 1, 2. Okay, you need it, yes, in order for us to get the vertex of your angle, I mean the point between the two edge views of the two surfaces. Labels are very important, yeah. Okay, then we will draw. So we will draw, okay, the third, right, which is your top view from these views. So first, we have to identify if any of the lines, this, okay, intersection, line or intersection, 1, 2 on the front, 1, 2 on the right. So any one of them, okay, parallel to the full line. Okay, you have to look at it very carefully, and they're not parallel to the full line, definitely not. Yeah, here this guy has angle right there, and that guy also, see, there's an angle not parallel to the full line. So that's the first thing you determine. Okay, so therefore we have to solve with the alternative method in this problem to get the true angle. So what's the alternative? We got to, get a parallel full line. So because this one is useless, yeah, we can't do it. So let's project another second full line that is parallel to the line or intersection. You can't choose either one of the view, right? We choose the front view because it's easier to draw on this side. If you chose this one, it's very difficult to draw on that side or on that side, okay? So it's better to view at your convenience, of course. And that's up to you, yeah? Me, I usually choose the view that is easier for me to draw with a spacious view, okay? All right, one moment, I'll be back. So now we have a second full line, yes, parallel to the line or intersection. So we gotta transfer the data to our first primary, yeah, auxiliary view from there. We do the same thing, direction of your dimensioning, so your distances, right? Make sure you keep the distances. The distances come from your reference plane, which is your full line, yeah? to the points. Yeah, so we keep these things and project it, and then we're going to close all of that. Okay, so here is your line 1, 2 edge view. Yeah, we got the edge view first. Then we're going to close all of the other points. Yeah, point 1, 3, 2, and 4. See, yeah. We also label the actual surfaces. So surface A is your 1, 2, 4, because here set is so 1, 2, 4 surface A, and 2, 3, 1 is your surface B. So 2, 3, 1 is surface B, and this is your true length. Yeah, because it's been projected from the line that is parallel to the second full line. Okay. Then we're going to project, all right, the third projection is coming out. All of your projectors line, okay. Then we're going to throw the third full line because we need to produce the top view out of it. Yeah. Again, measurement, always measure from your reference plane, which is this guy. Yeah, from here, here, here. So we do the same thing. Yeah, out, get the points, and here connect it. Yeah, so you get 3, 1, 2 fuse because it's on the same line, and then your point 4 is right there. That's the point of intersection of the two lines. Yeah, and the angle in between them is your true angle. So 3, 1, 2 is your surface B, all right, line, and then 1, 2, 4 is the surface A line, okay, in edge views, of course. So this is your primary, yeah, and then this is your secondary auxiliary views, and this is your middle, yeah, view. Okay, well that's it for the example 2.